All right, my Algebra 2 honors students. This is my second YouTube series that we're going to do about test reviews. So this is going to be about the Unit 3 test review, which you can see at the top right corner. So things that we're going to start with is this stuff, which should just be Unit 1 review. So Unit 1 review is all about key characteristics of functions. And since we're talking about absolute value functions, we're supposed to be able to see these things very quickly. So a vertex is that little spike right there. Remember, it's always x comma y, so 3 comma negative 2. The axis of symmetry is always going to be equal to the x value of the vertex. So in this case, it's x equals 3. A different way to visualize it is if we draw a straight vertical line like that from the top to the bottom. So we see that that is at the x value 3, which is x equals 3. The domain is always going to be all real numbers. There's different ways to write it, but I'm sure you guys like this one, x such that set of all x is a part of all real numbers. That means all real numbers. Basically saying from left it goes forever and to the right it goes forever. Now the range is how low it goes to how high it goes. So here I'm going to write it in inequality notation. So negative 2 is less than or equals to y, which is less than infinity. With that little line underneath the inequality symbol for negative 2 because we're at negative 2. We're touching it. Finally, we see our x and y, x-intercepts and our y-intercepts very easily. 0, comma 4. I'm going to plot them in red just in case it isn't so clear for some people. It's right there. So for these types of questions, we want to see how these transformations affect the parent function. The parent function is always going to be this v that comes out of the origin. So the way that that v changes with these transformations is, okay, this negative 2 means that it's going to move 2 to the right. This plus 3 means it's going to go 1, 2, 3 up. And that negative in the front means it's going to open downwards. So we're going to have points like this. Boom, boom, all the way down. Giving us a function that looks like this. A transformed function. There we go. So from here, we can see all these key features just as easily as we did before. So that little spike right there is going to be the vertex, which is 2, comma 3. The axis of symmetry is always the x value of the vertex, which is x equals 2. Domain is all real numbers. This time, maybe give to me an interval notation, which is 2 infinities. One infinity and another positive infinity. Negative infinity and a positive infinity. Range is all the way down, which is negative infinity. All the way up is 3, inclusive, because it touched that 3. Finally, these key characteristics are very easy to see. So that's a negative 1 comma 0 and a 5 comma 0 with parentheses around it. Finally, we got a 0 comma 1 for our y-intercept. You can just disregard this stuff. I don't think we're going to have to deal with this stuff during the test. That's pretty easy. It's just about getting used to what these transformations do to this red parent function, the normal v that we're used to. And an extension of that is this. So if we see a function like this, which is the parent function, but it's translated 4 to the left, 1 down, and it's stretched by a factor of 1/2, then that means our function has to be, okay, well, it's stretched by 1/2, then it's x. 4 to the left means a positive 4, actually. Finally, 1 down means minus 1. So if we look at all this, we see that this one's wrong, this one's wrong, this one's wrong because of the plus 1. So it has to be D. So finally, we want to go back to this and break this down. So we got a minus 3x, or minus 3 absolute value of x minus 2 plus 7. So we're talking about the right question now. So first, you want to see that that minus 2 shifts it right to. Shifts to right. This plus 7 shifts it 7 up. Shift 7 up. That negative means that it's gonna open down. Finally, that 3, we like to use the word stretch. So we could say stretches by 3. So it's just about remembering these key characteristics with what transformations happen, or with how the transformations affect the parent function. So for these, I'm going to do 2 examples. And maybe once you get the hang of it, it wouldn't be that bad. It won't be that bad. So let's look at this top right one. We got 2x minus 4, absolute value of is equal to 8. So just remember, if it's a positive solution, that means we have 2 solutions. And that's happened because we isolated the absolute value expression. So now we got 2x minus 4 is equal to 8. This is going to be our first equation. Our second equation is going to be something like 2x minus 4, so the same. The only thing that changes is that that 8 is now a negative 8. So that last number will always change signs. And from here, we could just solve for x. We want to isolate the x, so we want to do plus 4 on both sides. Plus 4 plus 4. So we want to get 2x is equal to 12 on the top equation, and 2x is equal to minus 8 plus 4 is minus 4. And now that we got to a point like this, we see that we have x is equal to 6 and x is equal to negative 4. And it's good to see it in this notation, set notation right here. That's one big set that those x's are in. So now we could do another one that's not isolated. So let's look at the bottom left equation. So we see this thing, that x minus 10 is not by itself. So the way to get it by itself is to first subtract by 2 on both sides, giving us 4x minus 10 is equal to 2. From here, it's still not by itself, it's 4 times all that. So you want to divide that by 4, divide both sides by 4 actually, giving us x minus 10 is equal to 2 over 4. So I'm just going to write it as 0.5. Maybe you'll see why. So from here, now that it's isolated, we want to write both equations. So x minus 10 is equal to 0.5. That doesn't change. But the bottom one is always going to be negative 0.5. And we add 10 to both sides on both equations. We see that we get 2 values. X is equal to 10.5 comma and then 9.5 comma, or no comma at the end, but yeah. Give 2 values like that. So it's just about isolating these things and being able to solve for the solutions. So we move on to these types of questions, which are going to be extremely similar, but there's just going to be one extra step to find our solutions. So we're going to focus on this top one, this first one. Same thing, we just want to isolate it. So I see that minus 8, I want to do plus 8 to both sides, giving us x plus 4 less than or equal to 9. And from here, we make 2 equations just the same. So that means 1 x plus 4 is less than 9. X plus 4 is greater than negative 9. So the 2 things that change is that the inequality changes direction. So the top one was the same, but the bottom one flipped. And also the sign changes just as the previous examples do. But from here we could solve it like normal. Minus 4, minus 4, minus 4, minus 4. Giving us values, x is less than 5, and x is greater than negative 13. So we got our 2 values. And now that we got our 2 values, we could just go like this and make our little notches onto our number line, negative 13 and 5. So when we look at this first inequality, it's saying x has to be less than 5. So a number that's less than 5 is maybe like 4, 3, or 2, or 1, or 0. So we know that it has to be in between. just like that. Let me shade it in a bit more. Lastly, we want to make sure we got these big, thick, closed dots onto our values. So that's all there is to it. Just solve it like how we just did, like the previous examples, just adding that extra step of flipping the sign and even doing the number line. So another one that I'll do is the bottom right one. I feel like a lot of people get tricked whenever they see something like that. But that dividing by 3 is really just canceled out when we multiply by 3. So when we multiply both sides by 3, we get x plus 1 has to be less than 5 times 3, which is 15. From here we make our equations just the same. X plus 1 is less than 15. X plus 1 is greater than a negative 15. So it's the inequality flips, the sign changes from that last number. Giving us x is less than, so here we have to do minus 1, 14, and x is less than negative 16. Actually, not less than, has to be greater than. Perfect. So from here, we want to make our little notches just the way that we did. Let's take a look at that first number. X is less than 14. So that means, again, has to be plotted within the range inside. And still with the same dots. So just be careful of what line is underneath the inequality, what direction we should shade, and all that stuff. Finally, we got some questions like this. So Teresa builds chairs for fun. Before she can sell each chair, they must measure 80 centimeters in height, with no more than 2.5 centimeters in air. So it's asking us to write an absolute value inequality for the situation. So that means we got this format that I want you to follow, which I went over in class. X minus target, and because it's an inequality, it's asking us for an inequality, has to be written in less than the amount that it varies. The way that I explain it like this is we get this x value to be our unknown. That's what we use x for. We don't know what x is. So I want to use that for our chair height. We don't exactly know how tall it is. But we do know that we want it to be, our target height is 80 centimeters. But we know that it could also vary 2.5 centimeters. So using these values, we can set up that little equation that we made over there. So x minus 80 has to be less than or equal to 2.5. We just use those same values based on the equation. X minus target is less than vary. So this is part of our answer. It's understanding that that is how we write an absolute value expression for the stuff. But we could always solve it by our traditional methods. So like this, x minus 80 is greater than 2.5. So remember, the inequality flips, sign changes. Negative 2.5. At the end, this will give us values. X is less than, we have to do 80 plus both sides. So 80 plus 2.5 will be 82.5 centimeters. The bottom will be 80 minus 2.5, which is 77.5 centimeters. Giving us something like this. So these examples are going to be pretty similar, pretty easy to see what's going on once you finally get that form down. Let's take a look at the bottom right example. So the bottom right example is saying the average number of seeds in a package of cucumber seeds is 25. So we know that our target, how much we expect to have, is 25. But we know that it could vary by 3. So our vary is 3. Since it's an equation, we want equal sign. So that's why we write an equal sign. Finally, we have values like this for equation. It's equal to 3. X minus 25 is equal to not a 3, but a negative 3. And from here, we could just solve for a set of x's, which is 25 plus 3 is 28. 25 minus 3 is 22. So it's pretty simple. If you know how to solve the previous problems, then I'm sure you could solve these. I hope I've provided you enough resources so that you'll do good on the test that we'll have on Monday. But if not, you could always reach out to me.